If you have tried building an AI agent recently, you know the exact moment the project stalled. You called the standard messages API. The model asked to run a tool, and suddenly, your engineering resources were diverted to building infrastructure rather than the product features you intended to ship. First, you had to write a custom loop to feed tool results back. Then came the state layer to persist conversation history. Finally, a local sandbox to secure dynamic code execution. You absorb severe security liability just to keep models from touching your core system. The engineering effort required to maintain the system often outweighs the work on the agent logic itself. Using the standard messages API for complex agents forces you to maintain the plumbing instead of the features. Claude Managed Agents is an Anthropic solution to this infrastructure tax. It is a server-side execution harness designed explicitly to take the loop, the sandbox, and the state layer entirely off your plate. The Messages API gives you direct model access and custom control, but you accept the full maintenance burden. Managed Agents offers a different trade, a pre-built structure where the execution loop happens remotely, requiring minimal maintenance from your local application. Because the execution runs entirely in managed infrastructure, optimizations happen under the hood. The system automatically handles prompt caching and context compaction without requiring any developer intervention. This transition allows developers to stop writing execution plumbing and start shipping static configuration. The entire Managed Agents ecosystem operates through the interaction of four discrete server-side primitives. We start with the agent. The agent is strictly a version server-side configuration resource. There is no agent running on your laptop. It is purely a blueprint. This blueprint stores your choice of model, the system prompts, the attached tools, and connected MCP servers. The second primitive is the environment. This is the isolated sandbox where the agent's shell commands and file inputs actually execute. An environment is either an Anthropic-managed cloud container or a self-hosted sandbox running directly on your secure hardware. The separation of duties is clear. The agent defines exactly what logic will execute, while the environment dictates exactly where that execution occurs safely. To turn a static blueprint into an active workflow, we introduce the third primitive, the session. This is the transient running instance binding your agent blueprint to your environment container. As the workflow progresses, the session natively manages conversation history, entirely eliminating the need for local databases. Signally, events form the bidirectional communication protocol, linking your client application to the running session. This is a critical architectural deviation. Unlike standard REST endpoints, the event stream does not return a single completed body. It returns a continuous stream of reactions that your application must parse as the work happens. Together, these four primitives completely decouple state tracking and code execution from your local machine. To see how this holds up, consider a practical use case, an asynchronous agent built to ingest a massive batch of vendor invoices, cross-check them against a master ledger, and flag any discrepancies. This task requires heavy file I/O. Pushing this workload locally would freeze developer resources, but with a managed harness, the spreadsheets bypass your local application and flow directly into the isolated environment. Once inside, the agent initiates internal API calls and executes the complex cross-checking logic entirely within the boundaries of that secure container. Even if the runtime stretches to 20 minutes, the session automatically tracks specific vendor quirks and accumulates the flag discrepancies, all without contributing state bloat to your local machine. Your application does not manage the granular execution steps. It simply monitors the event stream to receive final reconciled outcomes once the work is complete. Long-running, asynchronous, and outcome-shaped workloads are exactly where the constraints of a managed harness justify themselves. Building with managed agents requires understanding two implementation interfaces. You use the language-specific SDKs, available for Python, TypeScript, and Go, to handle application code, and the Anthropic CLI for direct terminal management. The CLI is useful for poking at agents and environments during initial setup. It allows you to configure resources and diagnose issues without writing custom scripts. Because this architecture is in beta, there is one strict requirement. Every raw HTTP request to the service must include the Managed Agents 2026-041 header. Omitting this specific beta header is the most common cause of initial HTTP rejection, mostly because the resulting errors often appear entirely unrelated. Looking at this dual-gauge visualization, you can see the architectural ceiling you must design against for session fanouts. Organizational rate limits are strictly capped at roughly 300 creation requests and 600 read and stream requests per minute. Achieving production readiness with this architecture requires strictly handling that beta header and architecting any massive fan-out loops to operate safely within those exact rate limits. You can certainly start in code, but the Anthropic console provides the most efficient path for initial prototyping. Inside the console, engineers visually draft system prompts, attach MCP servers, and run inline test sessions to validate the event stream in real time, all before committing configurations to an SDK. Once the agent behaves correctly, the promotion path is simple. You copy the generated agent ID and environment ID out of the console and drop them directly into your production code base. Relying on a hand-built local loop fails because of a simple reality. Building a robust agent harness is deeply complicated, and the harness itself was never the product engineers intended to ship. By shifting the burden of the loop, the sandbox, and the state layer entirely to Anthropic's managed infrastructure, system architects finally reclaim their cycles. You stop maintaining the plumbing and focus exclusively on configuring the behavior.